Hi GOH, this is Unit 6, Lesson 4, and today we're going to talk about rectangles. So a rectangle actually is a parallelogram. A parallelogram just means that both opposite sides are parallel. A rectangle is a parallelogram, but it has some more properties. It's a special parallelogram. All right, so a rectangle is a parallelogram with one right angle. Now, that doesn't mean that the other angles aren't right angles, okay? Because if I have one right angle, say that this angle right here in the bottom left corner was a right angle, well, that means the angle here has to be a right angle because opposite angles are congruent, and it means the angle here in the top left has to be a right angle because consecutive angles are supplementary, which means they equal 180, and it means the angle here has to be a right angle as well. All right, so it's a parallelogram with one right angle, or I could actually say it's a quadrilateral with four right angles. Whichever one. It's a quadrilateral with four right angles. All right, let's explore why rectangles must be parallelograms, even though it may seem obvious from the picture. All right, in this rectangle here, is formed by lines M, N, and P and Q. Give a justification for why angle M must be parallel to N and why P must be parallel to Q. All right. The lines that are perpendicular form right angles. All right. And right angles are congruent. So basically, let me put some angles right here. So I'm going to have angle 1 right here. How about I put a 1 there? And I'll put a 2 here. Okay? So those angles are going to be congruent to each other. All right? They're both right angles. So the picture shows me that this is a right angle. Therefore, angle 1 has to be a right angle because they are a linear pair. All right? Lines that are perpendicular form linear pairs. Lines that are perpendicular, form right angles, and right angles are congruent. So angle 1 is congruent to angle 2. If angle 1 is congruent to angle 2, they are corresponding angles, therefore those lines have to be parallel to each other. Angle 1 and angle 2 are corresponding angles. So therefore, M is parallel to N. And the same thing could be true with, say, angle, I'm going to call this 3, angle 2 and angle 3. They're congruent and they're corresponding angles. Therefore, P and Q have to be parallel to each other. All right, so a rectangle is a parallelogram, just so you understand that. A rectangle is a parallelogram. But there are some extra properties also. Besides having right angles, there are extra properties. We're just going to use a ruler right here in exercise 2. We're not going to use tracing paper, but using a ruler we're going to compare the lengths of the diagonals of the rectangle. So I'm going to look at QN, and I'm going to look at PM. All right? Just looking at them, you can tell that they're congruent to each other. All right? Are they the same? Absolutely they are. You can take out a ruler to verify that, but they are the same. Now let's prove why they actually have to be the same. All right, so here's my proof. I want to, let me see what I'm going to start with. I'm going to start, I know it's a rectangle, all right? So MNPQ is a rectangle. MNPQ is a rectangle. That's my given. If it's a rectangle, I know that MQ, this side on the left, is congruent to NP. MQ is congruent to NP because a rectangle is a parallelogram and opposite sides are congruent. So in a rectangle, opposite sides are congruent. because it's a parallelogram. They share this side on the bottom. QP is congruent to QP. That's going to be my reflexive property. A rectangle has right angles. So angle MQP and angle NPQ. So basically I'm saying this angle on the left and this angle on the bottom right are right angles. That's the definition of a rectangle. It's a parallelogram with a right angle. So definition, rectangle. If they're both right angles, that means they're congruent to each other. So MPQ is congruent to angle NPQ, and that is because all right angles are congruent. Therefore, my triangles are congruent. Triangle, now these are overlapping. Triangle MQP is congruent to triangle NPQ, and that's by side angle side. And if my triangles are congruent, then that means my corresponding sides, like MP and NQ, have to be congruent, and that reason is CPCTC. All right. Just a little math problem here. In a rectangle RSTU, so I have a rectangle RSTU. It doesn't matter where I put the RSTU, but they have to go in order. RSTU. It can go clockwise, it can go counterclockwise, but I can't be jumping around. Wherever I start R, S has to follow in order, whether it's clockwise or counterclockwise. So RS is 12, ST is 5, and what is the length of the diagonal SU? Well, remember, opposite sides are congruent. So let's draw in SU. And this is a right angle because it's a rectangle. Anytime I'm missing the side of a right triangle, you should immediately be thinking Pythagorean theorem. So basically I have 5 squared plus 12 squared equals x squared. All right, because my hypotenuse is my C. So 25 plus 144 equals x squared. 169 equals x squared. X equals 13. All right, so that was a nice easy one. Different from those proofs. There are some proofs in this chapter just to prove some of the properties that we are learning. Just as with parallelograms, we can prove something is a rectangle without initially knowing that all its angles measure 90. One of these ways uses congruent diagonals. In the diagram below, all we know is that ABC is a parallelogram whose diagonals BD and AC are congruent. Explain why triangle ADC must be congruent to triangle BCD. Well, we really just did that on the opposite side, and that basically this is congruent to this. So AD is congruent to BC because opposite sides are congruent. Okay. AC is congruent to BD. All right. And that's in my given. AC is congruent to BD. And that was the given. And CD is congruent to CD, reflexive. So therefore, triangle ADC is congruent to triangle BCD, and that's going to be side, side, side. These are overlapping. What does it tell us about angle ADC and angle BCD then? So ADC is right here, and BCD is over there. Is that those have to be congruent by CPCTC. CPCTC. How can we now use B to conclude that ADC and BCD must be right angles? They are same side interior angles. Same side interior angles equal 180, and they're congruent. So therefore, 180 divided by 2 has to equal 90. All right, let's look at this same thing with rectangles, but more with the coordinates. So using slope, distance, and midpoint, which I think most of you find a little bit easier. So in 5, I want to calculate the slope of all 4 sides of EF and GH. All right, so I got the slope of EF, I got the slope of FG, I got the slope of GH, and I have the slope of EH. I'm going to find slope 4 times. All right, so EF. Subtract the y's, that goes on top. Subtract the x's, that goes on the bottom. So 6 over 9, which is 2/3. Slope of FG. FG, so 2 minus 8. I subtract the y's, that goes on top. 7 minus 3, I subtract the x's, that goes on the bottom. And I reduce that, it's -3/2. Slope of GH, so that's going to be -4 minus 2. I subtract the y's, that goes on top. Subtract the x's, -2 minus 7. And that reduces to 2/3. And then EH, last side, is going to be 2 minus -4. -6 minus 2, which is 6 over -4, because this is -6 minus -2, and that gives me a -3/2. Now look at these slopes. Opposite sides have the same slope, and the sides that are next to each other, like EF and FG, those slopes are negative reciprocals. All right, so I know that EF is perpendicular to FG. I know that FG is perpendicular to GH. I know that GH is perpendicular to HE. And I know that HE is perpendicular to EF. Why? Because the slopes are negative reciprocals. Therefore, EFGH is a rectangle. They want me to calculate the midpoints of the diagonals. Remember, in a parallelogram, the diagonals bisect each other, and a rectangle is a parallelogram, so those diagonals should bisect each other. But let's figure it out. Let's make sure. Let's confirm the midpoint of FH. So I'm going to add the x's, divide by 2, and add the y's and divide by 2. Let me just make sure I have FH. So it's going to be 8 plus -4. Oops. 8 plus -4 divided by 2. All right, so that's going to give me 1/2, comma 2. All right, I got a fraction, but no big deal as long as the other one comes out to be the same. Midpoint of EG. Remember, I'm doing the midpoint of the diagonals. Midpoint of the diagonals. So midpoint of EG, again, I'm going to add the x's, divide by 2, add the y's, divide by 2, and yep, I get the same thing, 1/2, comma 2. So basically the diagonals bisect each other. And then they want me to calculate the length of the diagonals. So the length of the diagonals, so I'm finding the length of FH. x2 minus x1, -2 minus 3 squared, and y2 minus y1. That's okay, I have negatives because I am squaring them. So that's going to be 25 plus 144, which is 169, which equals 13. And you have to find the length of GE. Now we already proved in an actual and a formal proof that the diagonals were congruent. I'm just now doing it with the coordinates. So 7 minus -6 squared 2 minus 2 squared. So that's going to also be 2 minus 2 is 0, so this is radical 169, which is 13. All right, so it's a parallelogram because the diagonals bisect each other. They have the same midpoint, and the diagonals are congruent. Then it's a rectangle. So this is another way to prove something is a rectangle. You can either do the slope 4 times to show that the opposite sides are parallel and it has a right angle, or you can do the midpoint on the diagonals to show that they bisect each other, and then the distance formula on the diagonals to show that they have the same length. So your choice. I personally think it's easier to just do the slope 4 times. Otherwise, you do the midpoint twice and the distance twice on the diagonals. Okay, and that